This is section 1.1, part A, displaying quantitative data with graphs. To display the distribution of categorical variables, we used bar graphs and pie charts. Remember, categorical variables are the ones that put values or put things into categories. But how will we picture the distribution of quantitative variables? Quantitative variables are the variables that you can do calculations with. They represent a variable that you can manipulate. In this section, we present several types of graphs that can be used to display quantitative data. One of the simplest graphs to construct and interpret is a dot plot. Each data value is shown as a dot above its location on a number line. So when you're creating a dot plot, the first thing you're going to do is you are going to create your axis, and it's going to be usually a number line. You need to label what we're looking at. So let's say this is the number of pets, and we're talking about students in our classroom. So if we have students that don't have any pets, let's say we have 3 students that don't have any pets, we would put dots above 0, 3 dots above 0. We have 5 students who have 1 pet, then we would put 5 dots above 1. And we would keep doing this with all of our data values. Until we get a graph. These graphs are very easy to read. So if we look at an example, the 2004 U.S. women's soccer team was very successful. They went on to win the gold medal in 2004 Olympics in Athens. On their way to that gold medal, they had to play 34 games during the 2004 season, and we have a list of number of goals they scored. Now, just looking at that list, it's not very easy to read and interpret what it is, so we made a dot plot. So remember, to make that dot plot, you would draw a horizontal axis, which is a number line, but you need to make sure you label it of what we're looking at. In this case, it is the number of goals. You need to scale that axis, look for the smallest number and the largest number, and then create a scale between the two. And then you do mark a dot above the location on the horizontal axis. So it is very easy to see that there was only one game that they scored 8 goals in. There was 6 games where they scored 5, and there was only 1 game that they did not score at all. So again, it's very easy to read information off of a dot plot. Now, when we make a graph, that's not the end in itself. The purpose of the graph is to help us understand the data. So after making a graph, we should always ask, what do I see? So here are the general strategies for interpreting a graph of quantitative data. So the first thing you want to look at is the overall pattern. And we look for striking departures from that pattern. So you can describe the overall pattern of the distribution by its shape, by its center, and by its spread. You also want to look for any departures, which we are going to call outliers. So when we're talking about shape, there are 3 different shapes that we usually discuss: symmetric, skewed to the left, and skewed to the right. A distribution is roughly symmetric if the left side and the right side of the graph are approximately mirror images of each other. A distribution is skewed to the right if most of the data is on the left side and then the data stretches out on the right, and so our graph would look like this. A distribution is skewed to the left if most of the data is on the right and the tail of that graph is going to the left. So if we go back and look at the dot plot that we created of number of pets, our general shape, we have most of the points over here, and then it trails out over here. So that graph would be more skewed to the right. We can also look at the center. There are 2 different ways to look at center. You can look at the mean, which is the average of the data values, or you can look at the median, which is the middle number. Now later on, we'll say which one is more appropriate depending on what type of graph that you have. We can look at spread. There are different ways to look at spread, but for right now, a common way to look at spread is just to look at the range, which is the largest value minus the smallest value. And we can look at outliers, which is just something that differs from the overall pattern. Later on, we will find out different ways to do spread, and we will find a more distinct way to determine if something is an outlier. So you need to be cautious. The direction of skewness is the direction of the longer tail, not the direction where the observations are clustered. So think of a skier. He's skiing down the left side of this mountain, so this is skewed to the left. The Environmental Protection Agency, or the EPA, is in charge of determining and reporting fuel economy ratings for cars. Think of those large window stickers if you go look at a new car that's for sale. For years, consumers complained that the actual gas mileage were notably lower than the value reported by the EPA. It seems that the EPA tests, all of which are done on computerized devices to ensure consistency, did not consider things like outdoor temperature, use of air conditioning, or realistic acceleration and braking for driving. In 2008, the EPA changed the method for measuring a vehicle's fuel economy to try to give more accurate estimations. The table below displays the EPA's estimates of highway gas mileage in miles per gallon for a sample of 24 models of the year 2019 midsize cars. So of all these, they put them into a dot plot. Now we need to describe the shape, the center, and the spread of this distribution, and we need to try to determine if there are any outliers. So if we look at the shape, there are two clusters of values, which are cars that get around 25 miles per gallon. So we have a cluster right here. And there is a cluster from about 28 to 30. So this one doesn't have a very good shape. We can say that there are two different clusters. We have a cluster around 25, and we have a cluster from 28 to 30. The center for this one, if we were to go through and count off and find the middle number, so we cross them out and we go through and we go until we find the middle number would be located at 28, so the median is 28. So we would say a typical model gets about 28 miles per gallon. To find the spread, you find the largest value, which in this case is 33, and you would subtract the smallest value, which in this case is 14, and we would get a range of 19 miles per gallon. We also need to look for any outliers. So in this case, this 14 is all down here by itself. The next smallest one is 18. So it may be that 14 mile per gallon vehicle, which is a Bentley, is an outlier. And that 18 is pretty far away from the next one, which is at 22. So the vehicle that gets 18 miles per gallon, which is the Rolls-Royce Phantom, may also be an outlier. So below are two different sets of quantitative data. We need to determine if each graph is roughly symmetric, skewed to the right, or skewed to the left. On the first one, we do have our peak in the middle. It's going down on the right. The values are going down on the left. So we would say that one is roughly symmetric. Over here, our peak is more towards the right, and the data values get smaller, and it's stretched out more on the left side. So we would say that one is skewed to the left. Shapes of dots plots can have different shapes besides just roughly symmetric, skewed to the left and skewed to the right. As I said before, there were those two clusters when we were looking at the cars. Another way to describe them is to say they are unimodal, bimodal, and multimodal. So that one we looked at was bimodal because there was two peaks or two clusters of data. If there's only a single peak in the graph, that would be unimodal. And if there's three or more clear peaks, we would call that multimodal. So let's check our understanding. The Fathom dot plot displays data on the number of siblings reported by each student in a statistics class. We need to describe the shape of the distribution. Now we can see this peak of our data is on the left, and then it is stretched out to the right. So this is unimodal. There is one peak, and since the data is stretched out to the right, it would be skewed to the right. We need to describe the center of the distribution. Remember, to find center, there are two different ways. You can find the median or the mean. To find the mean, you would take all the data values, add them together, and divide by the number. So we would have 1, 2, 3, 0. So you would do 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1. And you would do that for all the data values. You would add them together and divide by the total number of data values. And in this case, that would give you 1.75 as your mean. To find the median, you would count in until you found the middle data value. And if you were to do that, it would actually be right between the 1 and the 2. So to find the median in that case, you would do 1 plus 2 and divide that by 2, or 3 divided by 2, which gives me 1.5 as the median. To describe the spread of the distribution, we can look at range. And remember, range is the largest value minus the smallest value. And 6 minus 0 is 6 siblings as the range. And if we need to identify any potential outliers, most students are down here in this group together. The 5 and the 6 are kind of off by themselves. So it is possible that the student who has 5 siblings and the student who has 6 siblings could possibly be outliers for this data set.